What's up, math fans? Today we're going to solve an equation when x is on both sides of the equal sign. And I'm going to use some vocabulary here. If I lose you, don't worry, I will re-explain what these words mean. But I'm sure you've heard these words before because you've recently watched my two videos. One is on one-step equations and the other one is on two-step equations. And if you can follow those two videos, all I'm doing is making this multi-step equation into a two-step equation so that I can follow those steps. So you really have to have that background knowledge first. So here's a multi-step equation. I see a variable on both sides of the equal sign, so I'm thinking I should combine like terms. And a lot of rookies make that mistake. They see a 2x and a 4x and they decide, oh, I'll just put them together, give me 6x. And that's not true if the x is on opposite sides of the equal sign. Cannot combine like terms here. You must instead what I call collect like terms. In order to collect like terms, I need to use my skills of additive inverse. So a lot of teachers will teach you bring the smaller amount of x's to the larger amount of x's. Let's pretend, so these are like terms for sure. How do I know that? Because it's the same letter and it's the same exponent. There's no exponent means the exponent is 1. Soon you'll see x with a 2 on top, x squared, or an x with a 3 on top, x cubed. But right now we're doing linear equation. The exponent is just 1. So I have my like terms, and I'm going to do the additive inverse of 2x, subtract 2x on both sides. Why is additive inverse so effective? Well, like I said in my other video, they're opposites. They cancel each other out, leaves you with nothing. You have 2 apples, you lose 2 apples, you have no apples. So they cancel each other out. Too many rookies also make this mistake. They'll do 2 minus 2 is 0, but they'll still drop the x down. And that's just not correct. You have no apples. If you put this, it implies you have 1 apple, but you have no apples. So don't write anything. Don't even write the 0. Drop down the 11. This is like $11. Equals 4x minus 2x, 4 apples minus 2 apples is 2x plus 15 drops down. And now we're right where we started and right where we left off in my last video. Two-step equation. So I do my additive inverse, subtract 15. Why do I do that? So that the 15 can cancel. 11 minus 15. If you're not comfortable with integers, positives and negatives, double check on the calculator. Try it in your head, double check on the calculator. 11 minus 15 is negative 4. Equal sign drops down, 2x drops down. Divide by the coefficient, and x is alone because the 2's cancel out. And 4 divided by 2 is 2, so that's going to be negative 2. And there's my answer. And let's say you knew that already because a lot of students like to say, they do guess and check. Oh, I know the answer is 5 or 2 or negative 2. I know it. I can just tell by looking. Great. Guess and check is a nice skill for beginners, but when these equations get more complicated, if you can't understand the concept of a two-step equation, you're going to get lost because I'm making it easy on purpose to explain it. It does get a lot more complicated, especially with decimals, especially with quadratic equations. So show your work. Teachers don't say that just to be mean. Show your work. But of course, if you're going to guess a check, you still have to prove the check. You can't just call the teacher over during a test and say, well, I know it's 2, because you have to be able to write it down with your own hand, which is what you're doing right now, right? What's a check? You take your answer, plug it in, or replace, or substitute into the original equation. And you learn the substitution back in middle school. So here we have, instead of x, we have negative 2 plus 11 equals 4 times negative 2 plus 15. And you're not sure, you're checking, so I'm going to put a question mark here. I want to make sure the left side equals the right side. Well, what else did you learn in middle school? Something called order of operations, or PEMDAS. So I'm going to do multiplication first. I have negative 4 plus 11. Does that equal negative 8 plus 15? It's not okay. Well, I guess it is okay. It depends on how lazy your teacher is. We want the left side to look exactly like the right side. So negative 4 plus 11 is 7. And yes, negative 8 plus 15 is also 7. So you want to go to this last step. A lot of lazy people stop here. Go to that last step, 7 equals 7. So if the left side equals the right side, you know your solution was correct. Negative 2 was correct. Okay? So don't go with guess and check. You want to go with solve and check. Show all your work. All right? This solution was done by bringing the smaller amount of x's to the larger amount of x's. A lot of teachers teach it like that. I don't teach it like that. I let you choose. You can do whatever you want as long as you keep the goal in mind. So I'm going to do it again with a different way this time, just to explain to you what the goal is. The goal in algebra is to get x alone. Isolate x, get x alone. And in order to do that, you have to understand that there's a balance. An equation is a balance. It's like a scale or a seesaw in the park. I don't know when you're going to see this video. Maybe there won't be parks anymore or seesaws, but let's imagine there's a seesaw or a scale. It looks like this. Whatever's on one side of the scale has to have the same weight or value as the other side. You cannot disrupt the balance. What you can do is add whatever you want as long as you add it to both sides, or subtract whatever you want as long as you subtract it from both sides, therefore keeping the balance. So your goal is to eventually get x alone and some number on the other side, and then you've solved for x. You've gotten x equals whatever, okay? So your goal is to get the variable alone and the constant on the other side. So my way, I always go for the variable on the left side. The way I just did it, I showed you it didn't matter. You can also just do constant equals variable. This way was the way I just did it. And why did I do it that way? Because some teachers like your smaller x's to go to your larger x's because they're scared of negative numbers. Here, I'm going to do it where you get a negative coefficient, and that's okay. So, same equation, different first step. Here, I'm going to subtract 4x on both sides. So I'm taking 4 apples off this side, which means I'm taking 4 apples off this side to keep that balance the same. So now I have negative 2x plus 11 equals 15, because that whole thing canceled out. Those are inverses. Again, it's a two-step equation, so I'll do the inverse of 11. That will cancel. Now I have negative 2 equals 4. Notice the equal sign should be coming straight down. Too many people like to jump around. It's got to come straight down. Stuff is happening on the left side, stuff is happening on the right side. So again, I divide by negative 2, and same conclusion, x equals negative 2. Obviously, it's going to be the same check, but I'm just showing you that I've reached my goal. Both methods work, okay? So you want to utilize inverse to collect like terms, not necessarily combine, although there are problems where you have to combine. Keep your balance the same and make sure you do your check. All right, thanks for watching. See ya.